Stanford University.
Welcome to CS 193P, Lecture 7. Today we're going to be talking about navigation and tab bar controllers. So we're going to take some of the kind of abstract, a little bit theoretical stuff that we were covering on Monday and put it into practice and actually start putting together some apps and customizing them in some interesting ways. And this is going to be highly relevant to the present assignment. So if you're working on the present assignment, Presence 1, and you're kind of stuck, if you refer back to this lecture or the demos that we're going to be doing during this lecture, there should be a lot of hints to point you in the right direction. A couple of announcements, as usual. Assignment 3 was due last night. If you're using a late day or 3, maybe you're still working on it, and if so, ask questions often and early. And then Presence 1 will be due next Tuesday at the usual time, 11:59 p.m. So, assignments are going to be due on Tuesdays from here on out. And so, yeah, you might want to assess your late day situation and, just be aware of where you stand, because once you've burned all your late days, a single late day will actually bump your grade from, say, a check plus to a check, or a check to a check minus. So it starts to get pretty harsh. Just wanted to give you a heads up about next Monday's lecture. We're going to be covering scroll views, table views, and a preview of Presence 2. And we're going to have a guest speaker from Apple, Jason Beaver, who's a UIKit engineer. He's going to be up here talking a little bit about table views. And really, if you have any UIKit related question, this would be a great opportunity to get inside the head of someone who's written a lot of code that you're using in UIKit. So that's next Monday. It'll be televised as usual. It's a regular lecture. And then this Friday, as I mentioned last class, we're going to have a session on preparing your app for the App Store. So what some of the issues are in terms of navigating the approval system and getting your app up on the store, and basically what happens from start to finish. So it's, again, very valuable if you want to publish your app. And also, next Friday, we're going to have a special guest, Loren Brichter. He is the author of a Twitter app, coincidentally, called Tweety. It exists both on the iPhone and on the Mac. It was recently released for the Mac. Got some obligatory icons to pop up here, but they're not popping. There we go. Freeze frame the video and you'll see the beautiful icons. But that should be a really interesting lecture. Loren is a former iPhone team member who's off doing the indie software developer thing, and there should be some great insights there. So today's topics: navigation controllers. We'll take a brief detour and talk about how to get data between view controllers. If you've got like a sort of parent-child relationship, what some of the ways are to communicate between them. We're going to talk about customizing the navigation experience, so a lot of the really common ways to customize what your user sees and some of the ways they might want to interact with your app. We're going to talk about tab bar controllers. As you recall from last lecture, we touched on these, but we're going to actually look at some code and actually build some apps here. And we're actually going to take a look at how you would combine a tab bar controller and a navigation controller. So do we have any questions before we get going? Any leftover assignment 3 stuff, or Presence 1, or last lecture? We're good. All right. If you're watching at home, you might want to turn your thermostat up to about 87 degrees just to accurately reflect the experience of being in class today. It's not the same without it. Yes? The question was, where does the app delegate fit in with respect to MVC? So one thing to keep in mind is that so UI application is a concrete class defined in UIKit. And the app delegate is a class that you define. There are many, for every application out there, probably has its own app delegate. So this is a class that you define yourself that inherits from NSObject. The application delegate typically is pretty much firmly entrenched in the controller side of things. So it knows about things like your application lifecycle and when it's an appropriate time to save data, or it's another one of those sort of tie everything together sort of classes. It's a controller class. And we're actually going to be talking a little bit about where the app delegate fits in with view controllers today and how you might want to make it fit in. Yeah?
How about the view controller class? Where does that belong?
The view controller class itself?
Is it a controller?
It's a controller for sure. Yeah. So the question was, where does the view controller class fit in? It's designed to be a starting point for your controller logic. So yeah, it's It's the one it's got some references to some model objects, it's got references to some views, and it's bringing them together and helping them to play nicely without knowing too much about one another. So good question. Yeah. Right. That's another really good question. And we actually got several emails about that. The question is, when is the right time to be manipulating user defaults? For example, in assignment 3, where there was some state to persist out, should that be happening in your controller or in your application delegate? Really, either way, especially for assignment 3, either way was fine. User defaults are something where you can access them from anywhere in your application. Generally, you want to be reading and writing to user defaults from the place that has the sort of best, what's the word I'm looking for? Locality. The thing that is most intimately related to the state that you're trying to persist. So, me personally, I would probably put both the loading and the saving code in my controller, because you can always be assured that that code, like you can write to user defaults and it'll get flushed out to disk when your application quits. Another option is to put that in your application will terminate delegate method. If you're going to do that, then your app delegate will need some way of getting the current state from the controller. So you might need to have some methods on your controller so that the app delegate can say, hey, give me your latest state and I'm going to save it. So there is a balance between wanting to have everything in one place and wanting to have good locality in terms of this is the controller that was responding to the plus and minus button presses, so therefore maybe that should save it. I wouldn't say that there's a really strong, none of the approaches that were sent to us in emails as questions were horribly wrong. So does that sort of make sense? Yeah, it's a judgment call. Yeah.
Is there any issue with writing to user defaults that frequently, like on every action?
Another good question. Is there an issue with writing to user defaults that frequently? I would hesitate to write to user defaults in the middle of a tight loop where you're going through tens, hundreds, thousands of objects, and you're just slamming user defaults. That's probably a bit excessive. One thing to keep in mind is that user defaults, though, actually doesn't hit the disk every time you call setObject for key. It'll sort of flush out to disk, on a schedule that makes sense to it. You can force it to flush to disk by calling this synchronize method on NS user defaults. So if you're worried that your application might crash and you want to make sure that your state is flushed out and you really need that state to be saved, then you might call NS user defaults synchronize at some. That's definitely something you wouldn't want to call over and over and hammer on it. But synchronize will be called automatically when your application quits cleanly, i.e. not from a crash. So you don't need to call synchronize from application will terminate or anything like that. So because of that, that's why it's okay to write to user defaults sort of as needed from your controller, and then assume that it'll be safely synchronized by some of the other application lifecycle stuff. Yeah.
That's just for user defaults, right? That's not dictionary.
Correct. The question was, that's just for user defaults, not for, generally speaking, for dictionaries. Yeah, I mean, if you've just got, NS user defaults behaves a lot like a dictionary. I mean, under the hood, it kind of is a dictionary. But if you've got your own dictionary, something, NS dictionary, alloc in it, you've set some keys and values in it. I mean, that's completely up to you as far as how and why and when you're going to persist that. We're actually going to talk about that a little bit in next Wednesday's lecture. We're going to be talking about this thing called property lists, or these things called property lists, which are basically serialized dictionaries and arrays and NS numbers and NS strings. So if you had some arbitrary dictionary that you wanted to save out to disk, there's a method that you can call to basically turn that into a file on disk. And on the flip side, there's a way to take a file on disk that was written out that way and read it back in as a dictionary. So that's very similar to, but separate from NS user defaults. A reason you might want to do that is, NS user defaults kind of gets pulled in all in one big chunk. You can't bring in part of it. So you probably don't want to store, hundreds of kilobytes or even megabytes of data in NS user defaults, because that's going to hurt the performance of your app launching and all that sort of stuff. So if you had, this big chunk of data that you didn't need immediately in your app, maybe you would store it in its own dictionary, write it out to a dedicated file, and read and write it as necessary. So we'll be talking a lot about those issues next Wednesday. Yeah.
Testing purposes, how can you clear the user defaults?
The question was, how do you clear user defaults? Is it, if Troy brings up the nsuserdefaults.h header.
Oh, well, you can also do it in the simulator just by resetting
Oh.
hardware setting.
Right. So if you just want to clear it out for testing purposes, there is a command in the simulator. I believe it's under the hardware menu, where you can kind of blow away some settings. Not sure what the name of that command is, but you can do that. If you want to do this programmatically from within your code for some reason, I believe there's a method in nsuserdefaults. The name isn't coming to me right now.
Set standard. It's just reset.
It's just reset standard defaults or something. Yeah. Okay. So
Reset standard user default.
reset standard user defaults. So that's if from within your code you want to blow everything away. That's how you do it. Yeah. The question is there a way to get the debugger to continue printing NSLog messages if you've started a debugging session and then you quit the app and then you relaunched it?
Yeah, I think this is relevant to this issue of persistence, right? Because you want to test that by quitting the app and starting it up again. Meanwhile, you
Sure. Yeah. Well, so I mean, one way to check that is just by doing debug and build debug and go. I think from Xcode, Apple Y will actually launch your application in the debugger, and you'll be able to set a breakpoint anywhere in the application lifecycle as early as you want, and you can break in there. If you're specifically talking about log statements, anytime you run from Xcode, those log statements will show up in the Xcode console output, whether or not you're debugging it. Was this for the simulator or on the device?
I think if you hit the home button on the simulator, run the application again inside the simulator.
Oh, but you run it again by clicking in the simulator? Yeah, that'll get outputted to the system console. There's actually an app in applications/utilities called console, and you can see any application output there. It'll be mixed in with all of your other sort of Mac OS X application output. So if some desktop app is spewing a bunch of stuff to the console, you might have to pick through it, but you can check in there. Yeah.
You can set filters.
Oh, and you can set filters inside console.app. So if you're just looking for a particular app, you can see log messages in there. But really, I mean, launching by tapping on the app in the simulator versus launching by hitting Apple R or Apple Y in Xcode should be more or less equivalent. The simulator may sort of restart, but in both cases, your application is getting launched, is going through the regular sort of app startup type stuff. Does that make sense? Okay. Any other questions? Those are good ones. Yeah, let's get into this. So we're going to talk about navigation controllers. And if you recall from Monday, navigation controllers are designed to manage a hierarchy of view controllers. So it may be a simple sort of linear relationship where you've got, a grandparent and a parent and a child, or you may have a complex tree where there's a lot of different branching options. So there are a lot of different types of apps that fit into the sort of navigation flow. And basically what a navigation controller is, like I said, it's a stack of view controllers. For those of you, most people here are probably familiar with basic sort of data structures in computer science. But a stack is basically a first in, last out, right? Yeah, first in, last out, where you're adding things to the top of the stack, and then you can pop things off while leaving the items at the bottom unchanged. And it manages that stack of view controllers along with the navigation bar at the top of the screen. So it sort of has this sort of dual state where it's got the nav bar reflecting what you're seeing in the area down below. And if we actually dig a little bit, how it all fits together, the area below the navigation bar is the content from the top view controller in the stack's view. So if you've added several view controllers to the navigation controller, the last one that you pushed, is going to be displayed in the area below the navigation bar. So this brings to mind, the size of that view. The view is going to be sized to fit the space underneath the nav bar. So even if you were laying it out in Interface Builder, and you had 460 or 480 pixels of vertical real estate, when the rubber meets the road, you're only going to have, if I can do my math correctly, 20 pixels, 44 pixels. You're going to have, 480 minus 64, so 414, yeah. 416. Yeah. So you need to be flexible. If you remember what we talked about at the end of last lecture, there are these things called auto-resizing masks where you can control when a view's super view changes size. You can have it grow or shrink. You can have it pinned to the top or to the bottom. So that's pretty valuable in a case like this. You've also got the top view controller's title automatically displayed in the center of the navigation bar. So typically when you're using a navigation controller, it's very rare that you will access with the nav bar directly. The state of the navigation bar will be updated automatically by the navigation controller to stay in sync with what you've been pushing and popping. So as you might guess, the title that we're getting in the back button is actually just the title of the previous view controller in the stack. So again, this is not something that you typically set the title of by yourself. There are some ways to customize it that we're going to talk about later. But this is something that more or less happens automatically by virtue of just pushing, popping, or setting the stack of the navigation controller. Do you want to? No, cool. You might wonder about the little plus button in the upper right. We're going to talk about that in a little bit, how you customize that. Any questions about how this fits together? So you'll tend to think about the navigation controller pretty abstractly, just in terms of pushing and popping and what its stack of view controllers is. And it sort of abstracts the specifics of the view transitions, the sizing, and updating the navbar state. So as I was alluding to just a moment ago, you're often going to want to modify the navigation stack in response to a button press or a table row selection or who knows what. Maybe at application launch time, you want the user to start 10 levels deep in this navigation hierarchy. They're launching the iPod app, and you want them to restore to the album that they were viewing the last time, even if that album is within an artist. I should probably be doing it this way. The album is within an artist, which is within your entire music library. So the two operations, first of all, there's pushing. And again, those of you familiar with stacks are in a lot of places in computer science. If you're not familiar with stacks, you can just Google for it. Wikipedia has a good article on stacks within the context of computer science, and that'll tell you a lot about it. But basically, to add a view controller to a navigation stack, you will call push view controller, and you can pass a little flag whether or not you want it to animate or just sort of instantly appear in place. Typically, if you're modifying the navigation stack in response to user actions, you're going to want to animate. That sort of gives your user a little bit of context. It hints to them, where they're going, and it gives them a sort of visual map of like, okay, the last view has slid off the screen to the left, and this new one came in from the right. It gives it a nice sort of concrete physical nature. If you're launching your application and you want to go several levels deep, you probably pass animated no. There's a way to set just an array of view controllers if you want all at once, but that's probably less common. On the flip side, popping is how you remove a view controller from the stack. You don't pass necessarily an argument in terms of which view controller you're going to pop. By default, it's just going to pop the top view controller off the stack. There are a couple of variants of this. If you want to look in UI navigation controller.h or the documentation, you can actually pop to a specific view controller, or you can pop all the way to the bottom if you need to do that for some reason. And again, there's an animated flag, so you can control whether or not it animates. Yeah, question?
So, two things. It seems that the pop view controller doesn't return a view controller, so it's not a regular stack.
Yeah, actually, anybody want to whip up my navigation controller.h? It doesn't return it? Yeah, I suppose there are a couple of other methods which do return it. Are you sure? We're checking with the judges here. A race between Al and Troy.
Pop view controller does.
It does. Hey! So the slide is incorrect. We'll get that updated. It does return the item that was popped. If you wanted to, you could ask before calling the pop. You could say, get the top view controller, retain it, and then do the pop. But actually, it will be returned to you. Right. So that's a good question. So the question was, what happens in terms of retain and release when you've got a navigation controller and a stack of view controllers? A navigation controller will retain all of the view controllers in its stack. And when you pop, I'm not sure if it's auto-released or I don't think it's released immediately. I believe we auto-release the result of pop view controller animated. So you can still sort of, if you need to, take that thing and retain it if you wanted to hold on to it for some reason. But it's sort of like UI view with subviews. UI view, a view will retain its subviews, and when they get removed, At that point, it's up to, if you want them to stay around, someone else needs to be holding onto them as well. Does that answer the question, more or less?
I mean, it's more like if you think about how you can scroll back and forth. Just say there's two panes, right? You want to scroll back from this pane to the other one.
Right, you want to go back from B to A. A was the first one.
Yeah. B to A, and then go back from A to B again. Then
Right.
put that into Pocket and then push it back.
Yeah. Yes. The question is, if you had A and B, A was at the root and B was the top view controller, and you wanted to go back to A, and then you want to wait for a little while and then go back to B, or you want to sort of do it right away? Wait for a while. Yeah. You would either, when you pop B, you would be retaining it someplace and then repush the same instance, or if you wanted to, maybe you would just let it be deallocated and you would instantiate a new object of type B and push it. So there are trade-offs there. It might take a little bit of time to reallocate a new B to push onto the stack, but the advantage is you don't have memory sitting around that's not being used. It probably depends what's in your view controller, whether it's really cheap or really expensive to create. Does that make sense? Okay. Yeah. So the question is, do the different view controllers in the stack, do their views cover one another? There's, in the context of a navigation controller, only the top view controller's view is displayed. Right. So the question is, what is the value of all the other stuff in the stack, apart from the one that's being displayed? The value is that when your user hits that back button, there's actually, well, we'll talk about this in the next slide, but that pop by hitting the back button in all these apps, when you're viewing, a playlist and you want to go back to the top level of your music library, when the user presses that back button, you don't have to write any code for the navigation controller to notice the back button press and pop and re-show the thing that was underneath. So, I mean, really, it's maintaining state. It's, I guess, trust me, that there is value in having those other view controllers exist in the stack. But both for simply displaying the back button, it's got to know what the title of the previous thing in the stack was.
And there is no forward button?
There is no forward button. It's that would be kind of like predicting the future, because, I mean, not necessarily. That's true. Sure. Yeah. The question is, why isn't there a forward button? There are apps where it is a very clear, like I said, a linear. You know that if you're going forward from, what's an example? Yeah. Although you don't necessarily know which song you're going forward to. Yeah. Yeah. There is no forward button. Typically, navigating forward is done by pressing a button or selecting something or stuff like that. Yeah.
If I can just add to that. So what I've seen in terms of apps, generally, if you think about how these things are used, it's oftentimes a table view, and then you pick an item in the table view to navigate into it. And so oftentimes what I've seen is that these apps generate the view controller that they want to display at the time of selection. Then they push that onto the stack. And when it pops, it goes away completely, gets deallocated, and then to decide what gets, pushed forward again is all on demand. So it tends to be on demand that way, if that helps.
Especially if you think about an app like Address Book, where if you're viewing an address book card and you select an address versus selecting a phone number versus selecting, there's all sorts of different directions you can go in. I mean, forward doesn't really make sense. I would probably argue that the number of cases where you're definitively going forward to this particular thing with this set of data without selecting something from the context, from the data they're viewing, is pretty rare. But there are cases for that. And we'll talk about how you can customize the appearance of the navigation bar such that you could have a button there, which maybe pushes something. So we've got pushing and popping. And we talked about this a little bit a couple slides ago, but let's sort of go through the startup of your app and how you get your first view controller onto the stack. So here's just a sample. And we're in our application did finish launching method. And in this case, we're creating a navigation controller programmatically. There are a lot of cases where you'll have the nav controller in your main window nib. But here, just to be completely clear about what's going on, we're going to allocate and init a UI navigation controller. We're going to replace the batteries in the clicker. And we're going to push the first view controller. So presumably we've created this first view controller object already. It's probably a UI view controller subclass where it knows what it's supposed to display, whether it's a button or a table view or whatever. And for the first one, like I said, we're probably going to push it without animation, because when you launch your app, your user should just be where they are, where they're starting, if that makes sense. The other thing which is important is adding the navigation controller's view to the window. This last line of code is what causes the nav controller's view, which is actually a sort of composite view, which includes the nav bar at the top and the sort of the container for the top view controller. That is how you get that to display on the screen. So there's no magic as far as getting a navigation controller to display on the screen. UI navigation controller is a UI view controller subclass. So you can use it in any place where you could use a regular plain old UI view controller. So just as in our demo on Monday, we instantiated a view controller and we added its view to the window, do the same thing here with the nav controller. Question?
So let's say you did say yes for animated here and delayed 5 seconds before adding the sub view to the main window. Does that mean it's going to be animating off screen or something, or is it just kind of queuing it up, or what's the deal?
That's a good question. So what happens if you pass animated yes here? I can tell you, this is not guaranteed by the API, but I can tell you the implementation of the navigation controller will actually notice that there wasn't anything displayed before, and even if you say animated yes, it'll display it without animation.
Well, I guess the question is, but what's going on before you add that to the window? Is it doing something on the screen, or?
Right. So it's not really defined from a public standpoint. What's actually happening, and one interesting aspect of navigation controllers is that if you, let's say in application did finish launching, you push 5, 6, 7, 8 view controllers. One optimization that it does for the purposes of app launch time, you don't want to be loading 8 nibs and unpackaging all this stuff and getting, allocating all this memory just to display the last one that you pushed. So what it actually does behind the scenes, and again, this may change in the future, this is not like necessarily defined anywhere, but it'll try to be lazy about actually instantiating those views. So it'll wait for a little bit, and at some unspecified point later, it'll actually display the final thing. So you shouldn't necessarily depend on it, but that's kind of what's going on. Any other questions about this? Yeah. It returns an allocated object. So yes, this code right here is leaking. Presumably, the part that I left out here, which you can sort of wave your hands and pretend is there, is that nav controller here is an instance variable in our application delegate class, and you would maybe release it in the dealloc method, right? So in that case, we wouldn't leak. The code that you see by itself on the screen here is leaking a navigation controller in the absence of a release.
I guess my question was more about like the nav controller itself. Should there be a pointer?
Yeah, actually, I mean, this is sort of implying that it's an instance variable, so it probably is, yeah. Yeah, if I wanted to be really clear here, maybe I could have declared that as a local variable and then released it, except then nobody's really holding on to the navigation controller. Like someone should probably be retaining it through its lifetime. Otherwise, its view is in the window, but nobody's holding on to the controller itself and it might just float away. Okay. So from there, you're often going to want to push and pop, mostly push, in response to user action. So from within some action method, again, like a button press, you maybe create a new view controller, like Al was saying. Maybe you're not even sure what view controller you want to push until something gets selected, because maybe they're selecting an artist versus an album or something like that. So this is within, say, our first view controller. So this code is inside our view controller subclass. After we create that view controller that we want to push, we can actually get at our parent navigation controller by saying self.navigation controller. So from within a view controller, you can say self.navigation controller. If you're not actually within a navigation stack, that's going to return nil. It's going to be a no-op. So you've sort of got to, there are some assumptions you may need to make about whether or not you're in a navigation hierarchy or not. So the biggest difference here is that we're calling animated yes to animate the new view, the new view controller's view onto the screen. So these are the two common types of places where you'll be calling the push method. On application launch with animated no, or in response to user actions with animated yes. And you'll be doing this in Presence 1. As far as popping, another one of those like, hey, here's a method that you probably very rarely call. It is pretty rare that you will call pop directly, because like I said, before, pressing the back button actually automatically pops the top view controller. There may be some cases where you want to do a programmatic pop. I think in the remote app, if you get disconnected from your music library, it sort of shuffles you back to the very root level and says, connect to a Wi-Fi network or whatever. So, there are cases where you might need to do a programmatic pop, but it's pretty rare. And don't feel like you're missing out or you forgot something if you never call pop view controller animated from your code. Al agrees? Yeah, okay. So let's do a quick demo here to hopefully make some of this gel. We're going to write a simple little app with a button that's going to push another view controller. So I'm going to go select new project. If I want to, there's actually a template in Xcode entitled navigation-based application. This gives us a little bit too much as a starting point for the purposes of a demo here in class. It actually gives us a table view where you can select things in the table view and it pushes. So just to really illustrate what's going on here, I'm just going to start with a window-based application, which, as we've seen, is pretty raw. You've got a window, and then it's up to you what goes in it. Let's call this push and pop. So here we've got our, that's a little too big, and that's a little too small. Okay. So we've got our push and pop app delegate, usual stuff going on here. It's got a window. I'm going to declare an instance variable, which is a UI navigation controller. And I'm just going to call it navigation controller. And then I've got that declared. Inside application did finish launching. As I mentioned before, I'm going to create this thing. And again, you can do this in Interface Builder or you can do it in code. If you're interested in the Interface Builder case, you can create a new project using the nav controller template, and you'll get that. Let's just do alloc init, and then window, add subview, navigation controller dot view. And just to please the memory management gods, let's do navigation controller release down here in dalloc. So what's this going to do here? I haven't pushed or popped anything. I've just got a navigation controller in the window. If I build and run, we get a sort of blank navigation bar. Doesn't seem to do anything. We've got this big white space down at the bottom of the screen. So we want to have a root view controller in here to display something. So we know how to do that already, right? We're going to do new file, and we'll create a UI view controller subclass, and we'll call this one first view controller. Does that look okay? Yeah. And to go along with this first view controller, I'm going to also create a nib with a single button in it, and we'll just call it first view. And here we go. Crack this nib open. Actually, let's go back to the first view controller real quick, and we're going to add an action method. We're pretty comfortable with creating action methods now. It's going to be typed IB action, and we'll call it push, and it takes a sender. Now, what is, oh, there we go. What is IB action? Anyone know? Void. It's void, yes. It's just a special keyword that allows Interface Builder, when it's sort of looking through the header files in your project and knowing what methods should be able to be hooked up to, it's just a hint to Interface Builder. And one interesting thing you can do, actually, in a lot of places in Xcode, if you hold down the command or the Apple key and you double click on a symbol, whether it's a class name or something like IB action, you can actually see where it's defined. Here it's in UI nib declarations.h. So it looks like IB action is just a fancy name for void. And likewise, IB outlet actually turns into nothing at all when your code is compiled. These are just hints for Interface Builder. So we've got this method defined here. I'm going to copy and paste it into the implementation. And we won't do anything just yet. So let's just leave that blank and hook things up in the nib. So remember, there are two steps to have a view controller manage a nib. The first one is to set the custom class in the Object Identity Inspector. We're going to set that to first view controller. Second step is to hook up the outlet. We can do that from the outlet, from the connections inspector, or just by control dragging on the file zoner. And we'll hook up the view outlet. And let's throw a button in here. So if I go UI button, drag this in here, we'll call the button push. Let me know if I'm going too fast, but I figure we've kind of done a lot of this stuff before. And I'm going to hook that up to the push method. So from here, we've got this, and actually, let's give this guy a title. And a good place to give your view controller a title is in your initialization method. So we've got init with nibname bundle overridden, and I'm going to say self.title equals first. The other thing we're missing here, actually, anyone know what I'm missing to get this thing to display on the screen? What did I forget? I need to actually push it in here. So I'm going to pound import first view controller.h, and then I'm going to instantiate a first view controller. Let's just call it view controller, actually. First view controller, alloc, and I'm going to call init with nibname and bundle. So the nibname was first view, and the bundle you can just pass nil here almost all the time, 99.9% of the time. In every third-party app, you're just going to be using one bundle. So I've created this thing, and I want to push it on the navigation controller. So I'll call navigation controller, push view controller, animated no. This code will be up on the website, so if I'm going a little fast, you'll be able to peruse it at your leisure. Release it. So at this point, the navigation controller owns it once I've pushed it. And from there, we should be good to go. Let's build. There we go. I pulled in Alcanastraro. So now we have the title gets displayed in the navigation bar up here. And we've got this button down here, which I haven't implemented that method, so it's not going to do anything just yet. So let's fill that in. We're going to create a second view controller subclass. Cocoa Touch classes, UI view controller subclass. We'll call it second view controller. And let's give this guy a title. Whoa, didn't want to delete that much. Self.title equals second. And we'll give this guy a nib as well. I suppose we actually don't really even need to display anything, but we'll just put something in there to spice it up. Second view. Open up second view in IB, and as usual, step one, object identity. The owner is second view controller, and we'll hook up the outlet to the view. And let's add a UI sliders are fun. Actually, we'll do a UI label. So there we go. Now, if I build and run, well, probably nothing will still happen because I still haven't implemented this method. So here, in the push method, as we saw in the slides, we're going to instantiate a new view controller to push onto the stack. We'll say second view controller, alloc init with nibname, second view, bundle, no. And then how do we get to our parent navigation controller, assuming we're already in a stack? Self.navigation controller. So self.navigation controller, push view controller, animated, yes. And here, we don't really care about the second view controller anymore, so we'll release it. All right, now I'm going to build and run from Xcode. Get a warning, oh, it's undeclared. So remember before for first view controller, I did that import. We'll add one inside here because the compiler needs to know what this class is, what its superclass is, what methods are defined on it. Otherwise, it's not very happy. All right, build and run. And now from here, if I press the push button, the second guy gets displayed. So you'll notice that transition up there happened automatically. The back button is displayed automatically. I'm not writing any code to do the pop here. These are such common things to do in navigation-based apps that it all just sort of happens for you. So we had to write a little bit of code just to get things sort of set up and in place. But once you're there, you can sort of design these individual view controllers in isolation from one another and plug them together to make an app. Yeah?
What's an example of a use for a pop view controller? Because it seems like every single time you're transitioning from screen to screen, you're either pushing or you're using the built-in
Yeah.
application.
No, it's definitely rare that you'll call pop view controller animated. Maybe this second screen here is representing some network resource. It's like, I've got like a network file browser, and maybe I've got some code in the background which notices when that server goes away, and I don't want to continue displaying that info. So I might just do a programmatic pop there. Yeah.
One common example is if you look at the iPod application, when the song finishes, if there's nothing else after it, it goes back to the list. So there's a pop.
That's a great example. So these are the basics of pushing and popping. This is, if you are working on Presence One and you're kind of not sure how to get things put together, check out this code sample, and it should be pretty helpful for you. Now we're going to take a slight detour. Before we talk about customizing the appearance of navigation, we're going to talk about how you get data between these view controllers. So maybe in that first one, we've got a list of data. And when you select something, you want to show some detailed information about that data. If you've read over the Presence One assignment, that's what you're doing. So how do we pass that data across? So here's Presence. Here we've got Troy again, smirking away. So how do we get that data to, in this case, the detail view controller, so it knows what to display? Because presumably, if I click on Paul up here, that's going to display some different data, and I don't want to have a Paul detail view controller and a Troy detail view controller. I want to have a single detail view controller that takes a couple of input parameters and then knows how to do its job from there on out. So the way we're going to do that, sorry Troy, that's probably the last time I'll put that up there, at least that big. So here we've got a controller for each screen, right? We've got the list, and we've got the detail. There's sort of in a parent-child relationship. The list knows about the detail controller because it's the one who created it, right, in response to the button press. The detail controller is kind of floating around, doesn't really know what's going on. Somebody created it. It's oblivious. So how does the detail controller know what to display? Multiple view controllers may need to share data. This is a very contrived case, but there are, almost every app out there that has navigation needs to do this. So, and also one view controller may need to know about what the other is doing. So maybe on that second screen, on the Troy screen, we've got a, fire TA button. No offense. And when we press that button, we need to communicate back up to the list. Hey, don't display this guy in the list anymore. He's gone. So how does the detail controller communicate back up to the list? So we need to make that happen as well. So in terms of sharing the data here, one way that we would encourage you not to do is via global variables. You've probably heard this song and dance before. Global variables, they're super convenient. They make your code very difficult to debug and test and untangle. You end up in that, flying spaghetti monster situation again. So one way to solve this might be, quick and dirty, is to have your app delegate floating out there in space. Everyone is able to say from anywhere in code, UI application, shared application, delegate, and get the app delegate. So you could have the app delegate kind of know everything, and it's got all the list of people, and it's managing all the state. I would really recommend not to do that unless you're just doing a simple, you need to whip something up in 2 minutes to show to an investor, and you don't care about architecting it. So I would recommend that you not do this. The way that I would recommend to do it is to figure out exactly what needs to be communicated between these two, between the list and the detail. So once you figure that out, in this case, what needs to be communicated are the details of the person who we're showing more info about. And then define input parameters for your detail view controller. So this could be via a custom init method, where you've got, rather than init with nibname and bundle, it's init with person or something like that. Or you could just init it the usual way and then have properties. So after you created it, you would say viewcontroller.person equals Troy, something like that. So here we go. We've created this detail controller, and we created some data in the list, and we passed it along and said, here's your data to display. From here, let's say we want to communicate back up the hierarchy. So the detail controller wants to say to the list controller, hey, something happened that you might want to know about. So try to use loose coupling here. Rather than having the detail controller know anything about its parent, define a generic interface. And I'm going to show you a great example of this in a little bit. What you can basically do is provide a way for the list controller to say, hey, I care about certain things that are going to happen. And when they happen, here's a pointer to me. You can tell me about it. So then with the detail controller, something interesting happened. It's able to pass that back without knowing too much about what's going on. I hope you like the little animation. It took me about 7 hours to get right. Not really. Keynote is actually a very nice presentation application. So let's look at an example of this. The one I'd like to show you is if I hit Apple Shift D from Xcode, I can do this open quickly thing, which is very, very handy if you want to look at header files in UIKit. And I'm going to type UI image picker controller.h. So if I look through here, UI image picker controller, you might be fooling around with this later this quarter. It's a view controller subclass. It's actually a UI navigation controller subclass, which is pretty rare to subclass UI navigation controller, but for this case, it's got a pretty fixed stack of view controllers to display. And it's got, let's turn on wrapping. It's got, you can set things up. You can say, is source type available to figure out if your device has a camera, yada, yada, yada. And then here, there's this UI image picker controller delegate protocol. We haven't really talked about protocols, or have we? I guess we didn't, no? It's sort of like an interface in Java. It's a set of methods that some object may choose to adopt and implement. So you'll see back up here, there was a property on the image picker, the delegate property. So you could set some object as the delegate here. And then whatever object that is, the image picker controller, when it's done picking an image from the camera or the photo library, it'll message that object, typically its parent, speaking in kind of generic terms here. It'll say to that object, hey, I'm the image picker controller. Here's a pointer to me, just in case you forgot. I finished picking an image, and here's the image I picked. So the user tapped on an image, it'll pass that back and say, here's the image that the user selected. It'll optionally pass back some, an NS dictionary of the crop or maybe some other editing information. There's another delegate method, image picker controller did cancel. And again, it's sort of the convention for delegate methods to pass as the first parameter, as the first argument, a pointer to themselves, just in case, to avoid ambiguity, so you know where this thing is coming from. So if the user brings up the image picker and then hits cancel, whoever presented it and set themselves as the delegate is going to get this message about cancellation. So in that way, the image picker controller is in UIKit. It doesn't know anything about the app where it's being used. It doesn't know anything about who's using it, but it's able to be reused in a lot of different places. Any questions about that? Pretty cool. I'm preaching the gospel of reusability as usual. So that's a little example there. We're going to skip this demo, but I'm going to post it on the website. What I was going to show you was, that little UI label that we had in the second view controller. I was going to show, how you could pass along some parameter, and then, when you're creating the second view controller, say, here's the text that I want you to display. But we're not going to do that right here because there's a lot of other stuff I want to cover. Can you imagine how you might do that, though? You might have some custom init method for second view controller, or you might have a property where you say second view controller.text equals whatever. One thing to keep in mind, though, is that when you're doing that, the second view controller's view may not yet be loaded. It may not yet have pulled in the nib from disk. So you might need to, rather than assuming that you have a pointer to the label in your init method, it might be something you need to fill in like view did load. That's a great place to do that sort of thing. So there'll be some code for you to pick apart if you're curious about this on the website. Let's talk now. This is sort of the more exciting stuff of this lecture, customizing navigation. So there are a lot of different ways to customize the experience of navigation to provide both, functionality and aesthetic pleasure to your user without actually poking at the navigation bar directly. The nav bar is a great place to put controls that your user might need to get at, frequently. The world clock, it's got this edit button and the plus button up at the top. rather than having those down in the view someplace. Very prominent types of controls. Same thing for the recent calls list in the phone app. It's got this custom title view actually, which is a segmented control because that's a really frequent thing to toggle between, and it's also got the clear button. So this is a great place to put buttons or other types of controls, especially if they interact with kind of the whole screen, like this all mist toggle. Does that make sense? So this is a common place to put stuff. Before we talk about that, we need to know about UI navigation item. UI navigation item sort of describes the appearance of the navigation bar. The title, the left and right buttons. There's a couple other properties. You can have a custom title view. The key thing here with UI navigation item is that every view controller already has one that you can then customize. And it'll be displayed when the view controller, it'll be represented in the navigation bar when the view controller is on the top of the stack. So what you'll tend to do is, so here it is. The view controller has a nav item. The nav item has all these custom sort of properties. And let's take a step back here. So you'll typically in like your init method or your viewDidLoad method, these are good places to set up the appearance of the navigation item. So within your view controller subclass, you might say self.navigation item.right bar button item equals whatever. And then you've created some button with a little smiley face on it that opens up your user's smiley face objects or something. Was there a question back there about that? No, we're good. So this is kind of the lay of the land. Who owns whom? So let's talk about displaying a title. A title is actually an interesting case because titles are displayed in a lot of different places. You might want to display a title up in the navigation bar. You might also want to display a title in the tab bar. So it's a common enough thing that UI view controller itself actually already has a title property. It's declared in UI view controller.h. Properties, just like we've used properties before, it copies the string, and it's just called title. And the navigation item actually gets this title from the view controller automatically. As we've seen, the top view controller's title is displayed in the middle of the navigation bar. The previous view controller's title is displayed in the back button. So if I wanted to, actually we were doing this, I guess I did that a little bit early. In the demo, when I was setting the title of the view controller, this is how you might do it. This is from outside the view controller. I'm saying viewController.title. Or if you're within the view controller, you maybe say self.title like we did in the last demo. Titles are pretty easy stuff. Let's talk about left and right buttons. The way you represent these is via a special class called UI bar button item. These types of buttons are a little bit different from regular old buttons, UI buttons on the screen, because they're only displayable in navigation and toolbars. So it's a special object. It's not exactly a UI button, but functionally it's very similar. It's got a target and an action, just like a regular button. You can display a string or an image that you've specified, or there is a set of predefined system items for things like the camera and the little square with the pen in it for composing new messages. So let's look at how we might create some of these. First of all, text is the easy case. We want to display a little foo button in the navigation bar whenever our view controller is the top of the stack. So maybe in our viewDidLoad method, we'll create this UI bar button item. There's maybe a few more parameters to this than you might expect because there's a lot of ways to customize it. We're going to create this bar button item with a title, with the bordered style. The unbordered style is like in Mail where there's those buttons at the bottom of the screen that don't have the actual border drawn around them. And then a target and an action. Target action, this is old news by now. So the target here, oftentimes in a view controller, the target will be self. The target will be the view controller that has this thing. So I set up this bar button item. Whenever it gets pressed, it's going to call foo on us. And then I'm going to say, that slide is wrong. Self dot. I probably made the same mistake last quarter and then forgot to fix the slides. Navigation item. All right, pretend that never happened. Self.navigation item dot left bar button item equals foo button. And this will cause that button to be displayed when it's on the top of the stack. I'm guessing we have the same bug in this slide. Let's use a system bar button item. These are really frequently used for things like the plus, the camera, composition. There's a bunch of other ones. And you can actually check them out in UI bar button item.h. So let's do a plus button correctly. I don't want to confuse anyone because it just creates more emails to the list. So here, very similar. We're in view.did load. We want to use the system item. So instead of saying init with title, it was init with title, right? Init with bar button system item. Not the most brief parameter name, but we're going to use the UI bar button system item add. You'll notice a lot of these types of type defs, they start out with the same prefix, UI bar button system item, and then whatever. So you can sort of type and you can tab complete the first bit, and then you're left up in the auto completion scroller with just the UI bar button system items. It's kind of a nicety for Xcode users. Again, bordered style, target is self. It's going to call add on us, the view controller here, and then we set it on our navigation item so that it gets displayed when we're on the top of the stack. Any questions about that? No. There's a special case, which we're just going to kind of touch on. It's not necessarily required anytime soon. I don't know if it is actually at all. But edit done buttons are very common. You've got this button, see the top of the screen where you tap it, and it goes between edited and done, and maybe toggles some state in the view underneath. This happens in address book when you're editing an address book card, a lot of other places. If you want, I can replay that. Follow the bouncing ball, tap it, and it switches its state. This is kind of repetitive. It's used in a lot of apps to edit, edit the items that you're displaying. So every view controller, if you need an edit done bar button item, you can get to it very easily. The target action is already set up for you. So there's one line of code that you would write to display that thing up there. You would say self.navigation_item.left, in this case, bar button item, equals self edit button item. This creates a bar button item that's already pointed at the view controller, and it'll invoke a special method on the view controller when it gets pressed. It'll call this set editing animated method. So if you then wanted to customize your view, animate those little minus buttons in or whatever, you would just override and implement this set editing animated method. So we're getting into a little bit of trivia here. You don't need this necessarily right now, but it is kind of a nice convenience. You could obviously create something like this yourself, but who wants to write code that's already been written a million times? Custom title view, like we saw the segmented control in the mobile phone app. This is an arbitrary view that you can display in place of the title if you maybe want to display some custom content up there. For example, if we want to do some sorting, from ascending to descending in our list of whatever. So how do we get this view up here? Again, we go through the navigation item, and it's actually got a property called title view. It defaults to nil, which means it just uses the title. We would create this segmented control, however you want to create the segmented control. You set it as the title view, and we practice proper memory management, so we release it. Yeah, not the most complicated thing in the world, but that's how you get that kind of a view in there. Any questions about that? And then finally, the back button. This is something we get a lot of questions about. Sometimes you need a shorter back button. Let's say we've got this, the previous view controller, its title was hello there, CS193P. And that looks kind of silly when it's sandwiched in there in the back button. So what you really want is maybe you want a longer title when it's on the top. But when that previous view controller is being represented by the back button, you want to use a different title. So one thing that a lot of people try to do is to try and set some property on the detail view controller, which is currently being displayed. And that's not going to help you out here. What you actually need to do is set up a property on the previous view controller, the one that is being represented by the back button, if that makes sense. So here's code within the previous view controller. And we said our title, self.title, is hello there, CS193P. Within that same block of code, wherever you set your title, if you want a custom back button title, you can actually create a UI bar button item, because you can actually have an image. Like there's apps that use a little arrow in the back button. The iPod app does this, for example, because you may be viewing some artist that has a really, obscenely long name, or just an obscene name. We can't do anything about that here. So we would create this new bar button item, and we use a shorter title, in this case, hey, and we would say self.navigationItem.backButtonItem equals hey button, and then release it. So again, this is within the previous guy. I'm just going to hammer this in here. This is not in the detail view controller. It's in the one that is one level back in the stack, and that will cause this. Well, that won't happen, but it'll use a shorter title. So that's how you customize the back button. Let's do a quick little demo of some of these bits here, just to show you, prove that I'm not lying. So let's give this first view controller a longer title. How about, that's a little bit longer. I can't think of a longer title right now. So if we build and run here in the simulator, we've got numero uno, we push, and it's maybe not the longest back button, but we'd like to trim it down a little bit. So what I'm going to do is back here in the bit of code where I set the title, I'm also going to say UI bar button item back button item equals UI bar button item alloc init with title 1 style UI bar button item style. See how they all have a common prefix, so I can kind of choose between them in the Xcode pop-up here. So I'm going to use the bordered style. And actually, for the back button item, you just set the target and the action both to nil, because back should always take the user back. It shouldn't take them forward or up or down or anything like that. So I've created that thing, and I'm going to say self.navigation item. And remember, the navigation item gets created on demand the first time you ask for it. It's always there for you to customize. And I'm going to say back bar button item. I suppose I could use the same name in both places. Equals back bar button item, and then release it so we don't leak all over the place. So now if I build and run, minor little touches like this, but they really let your users know that you care about them. So now I've got the shorter title. Let's add a custom button to the second view controller here. So inside here, we could do it in init. We could do it in viewDidLoad. I'm just going to do it in init. I'm going to say self.navigationItem.write bar button item, because we don't want to hide the back button. If we did, then we would need to programmatically pop. Equals. Well, I suppose we should create something. Again, UI bar button item. Equals UI bar button item alloc init with let's do a system item. UI bar button system item, and then here we go again. We can toggle around in here. Let's do the compose one, because I work on mail and we do a lot of composition. Target is going to be self, and the action, let's just make it compose. Are you guys seeing this okay on the screen? So we've created our bar button item. We're going to set it, and then we're going to release it. Now, I'm going to need to actually implement this method, otherwise it'll crash. It'll say, actually, let's see what happens if I don't implement it. If I build and run here, and I push, and I click this button, you'll notice we get kicked back into Xcode. Xcode notices that something went wrong, and it'll actually say to us in the console, terminating app due to uncaught exception, invalid argument exception. It basically says, hey, we tried to call compose on the second view controller, and it was an unrecognized selector. That means it doesn't know anything, it doesn't know anything about the compose method, and it crashed. So that's what'll happen if you've forgotten to implement a method that you've set up via selector. So let's do, we can just do void here because we're not using it in interface builder. We'll do compose, ID sender, And let's create a UI alert view. These are fun for showing error messages. We'll say that equals UI alert view, Alec, init with title, can't compose, message, you haven't implemented anything like that. Delegate, we don't care about the delegate. We'll have the button just say OK, and we don't want any other buttons. You got UI alert view for free today. Alert view show is how you show it, and then we release it. So now, if I build and run, and again, this will be up on the website. If I do the push here, and I'm in here, and I click this compose button, it'll say can't compose. You haven't implemented anything like that. Lecture is too short. Yeah, so I can click away, and it'll keep doing its thing, and all that. So again, great place to put controls that your user may need to get at frequently. Let's go back to the slides. How are we doing for time? Ooh. And let's just keep going. Tab bar controllers. So again, just like a navigation controller, tab bar controllers manage a list of view controllers. In this case, like we mentioned on Monday, they're sort of parallel siblings. They don't necessarily know much about one another. So UI tab bar controller has an array of view controllers, and it manages the tab bar down at the bottom of the screen. And just like UI navigation controller, it takes care of all the positioning, all the sort of repetitive, sizing the view and displaying the views when the tab bar buttons get pressed that, tons of apps need to do, and they don't want to all write their code to manage that. So how it all fits together, we've got the selected view controllers view in the top part of the screen. Again, it's trimmed by 40 some odd pixels by the tab bar down at the bottom. We've got all the view controllers with their titles and some other custom properties, which we'll show you about in a minute, are at the bottom of the screen. That's it, actually. Tab bar controller is kind of a simple class, simpler than navigation controller, at least. It's got an array of view controllers. It's got a single selected view controller, which is reflected in the tab bar. If you want to set up a tab bar controller, again, application did finish launching. You may instantiate one. You may also set it up in a nib. For the purposes of illustrating this, it makes more sense to show it in here. You set its array of view controllers to some array, which presumably we set up already in our code. It's just an NS array. And then you add the tab bar controller's view to the window. So very similar to using a navigation controller. Now, from here, one thing to keep in mind is that view controllers can define their appearance, right? So they've got a title. They've also got an image, preferably something really snazzy looking that your interface designer has come up with. So to do that, there's a class called UI tab bar item, similar to UI navigation item or UI bar button item. It's sort of this class is an object which captures the appearance of these things in the tab bar. So it can be either a title with an image, or again, there are some special system items for really common things like bookmarks and what other ones are there? Favorites with a little star, all that sort of stuff. So each view controller comes with a tab bar item for customizing, or you can create your own and set it. So let's go through a couple of little examples here. We want to have a title and an image. So we've got this little playlists image, and we want the playlist title. The way you might do this is by instantiating a UI tab bar item. Set the title, set the image, and this image here is actually a black and white image where it's basically just using, actually, it's not even just black and white. It's an image where it's just using the alpha to determine what should be displayed and what shouldn't. Because when you select that tab bar item, it gets displayed with that cool sort of blue shaded highlighty tint to it. So basically, you just give it an image that just specifies the alpha, and it'll display it in the proper way for the tab bar. So you don't need to be sitting there in Photoshop trying to get the gray and black gradient exactly right. Also very common is to use system items, so bookmarks. Here, rather than specifying the title and an image, we just specify the system, the bookmark system item. And we would say self.tabbar item equals that. It takes this tag, which is a way of identifying the tab bar item, but it's pretty rarely used. We've got, what's that? Yeah, we've got 2 minutes. So you know what? I'm just going to run this demo because I cheated and I actually have it built for you already. Just to show kind of what's going on. Here we've got my tab bar, conveniently with some images already set up. If I build and run here, we need to quit push and pop. So here we've got a tab bar controller in a window. It's got 3 child view controllers, which are set on the .view controllers property. And when I click on the tab bar, I don't need to write any code to swap the view onto the screen and remove the other one and size it into the space. The tab bar controller manages that for you. So I can go between these views here. I think if you check this out when it gets posted, a couple of these are, I think this one, my view, is coming from a nib. The red and the blue ones are just programmatically designed views. So you can sort of mix and match those. And one really cool thing, if we go back to the slides just for a quick little bit, one pretty cool thing is that you can combine navigation and tab bar controllers. Well, actually, more view controllers. What happens if you have too many view controllers to display? Let's say we set 7 or 8 view controllers in the array here. It'll automatically display this special more item in the list. When you select it, it'll show you the overflow, the rest of the view controllers. It'll use the same actual black and white alpha image to create an image to display in the list. And the user can tap on these things, and they can actually customize which items go in the tab bar. That all comes for free with UI tab bar controller. If you want to combine navigation and tab bar controllers, like in many apps, iPod, the store apps, phone, you've got a tab bar controller at the top level, and then within each of those tabs, you may have navigation, right? The way you do that, and actually a lot of people get this wrong the first time. It's a very common mistake. Really, you want to have the tab bar controller at the top level. That's the one that you're going to add to the window. And from there, it may have several children. May have a plain old view controller mixed in with some navigation controllers. So this is kind of how it all fits together. Some people, you often read from the top of the screen. You say, well, the nav bar is at the top. So I should have a nav bar controller with a tab bar controller inside it. And that's actually backwards. So start with the tab bar controller. And if you have navigation in any of those tabs, then the navigation controller will be a child. Because nav controller is a view controller subclass, you can kind of mix and match it in there. We're not requiring anything like this, at least until Presence 4. So don't stress too much about it. The way you do this, you create a tab bar controller, create each navigation controller, and add them to the tab bar by setting the view controller's property. So we're rushing a little bit because we're almost done, but you can check this out in the slides when they get posted online. And again, you don't need to know this right now. And that's it. So we've taken this kind of abstract concept of view controllers, which we talked about on Monday, and we now see how we can fit them together, plug them into one another to make a pretty decent application.
For more, please visit us at stanford.edu.